series. If I is equal to the square root of minus 1, then evaluate the sum j is equal to 0 to 10 minus I in exponent j. And as we see here, this one is a finite geometric series, but just let me expand some terms, and j is equal to 0 to 10. So as we see here, it has a terms, this series. And if we are starting from 0, let's say minus I in 0, plus minus I in 1, plus minus I in 2. So whenever is a j, we are substituting with those numbers from 0 to 10. And those are the terms of this expanded series. And in the end is minus I in exponent 10. And as we see here, minus I in exponent 0 is 1. So this one here is 1, is equal with 1. And if we want to know to find the sum, we can find we can write the formula. So let me write the different color. So the formula is Sn is equal to a times 1 minus r in so let me erase, in exponent Rn plus 1 divided by 1 minus r. So this is the formula. But first of all, let's find those a and r, the common ratio between two terms, and the n. Because n here is the tenth term, n is equal to the 10. And a is equal with the first term is 1. And the common ratio r is equal with the minus I. So we already found this these terms, and now we can substitute those in this formula here. So S10 in fact, because instead of the n I'm writing 10, and here is a is 1 times 1 minus r is minus I in exponent 10 plus 1, and everything is divided by 1 minus I. So we are here. But we already see here S10 is going to be equal. So if I multiply by 1, all this expression is going to be just a whole this expression here, 1 minus, but instead of the minus, so this one I can write a minus I in exponent 10 times minus I in exponent just 1. And here is 1, negative times negative is a positive, 1 plus I. So that's what we have here. But just let me find out this minus I in 11, what it is, minus I in 11. So this one I want to find out. This is going to be minus I in exponent 8, which is, this is 1. And is a minus I in exponent square, but because it is a square, is going to be, is the same like a I square. I square is equal with the minus 1. Okay, and here in the end we have a minus I, which is minus I is minus I. And if we are multiplying here everything, 1 times minus 1 is a minus 1, and here is a minus I. If we are multiplying together, here is going to be I. So what it means, instead of the minus I in exponent 11, I am going to substitute with the I. So then the S10 is going to be equal. So here is 1 minus, and instead of this I11 or whole this pure imaginary number, I can write just I. And here is divided by 1 plus I. Basically we are done here, but if we want, for example, this one to rationalize the denominator, then we can multiply both up and down of the fraction with the conjugate of 1 plus I. The conjugate of 1 plus I is 1 minus I times 1 minus I. Okay, so let's see what we get. If we are multiplying here everything, we are going to get here 1 minus I times 1 minus I is 1 minus I square. And here is 1 plus I times 1 minus I is 1 square minus I square. So that's what we have here. And now S10 is going to be, so here if I'm distributing, the first one is going to be 1 square minus 2 times 1 times I, and is going to be plus I square. And here down is going to be 1 minus, and 1 square is a minus 1. Okay, so we are by the end. 1 is here, minus 2i, but I squared is a minus 1. And this here, 1, negative, negative is a positive 1, plus 1 is 2. And everything here is going to be 1. This 1, minus 1 we can subtract. What remains minus 2i divided by 2. And we can simplify 2 by 2. And S10 is equal with a minus I. So this is a series the sum of the series is going to be equal with a minus I. So this here is going to be equal with a minus I.